Hey guys, Mrs. Traver here. We're going to walk through our notes on property of exponents. There's going to be 6 properties that we're going to talk about today, and they're all going to deal with exponents, or in the case of the properties, we're titling them with the use of the word powers. Powers and exponents in this case are one and the same. So the first one, a product of powers, product means multiply. So we're going to be multiplying 2 powers. For example, x squared times x to the third. The way we're going to play out this section of notes, by the way, is I'm going to start with an example, and then we'll work our way to the property, and then we'll end up having that at the end. So here's an example to start, and the way we're going to come up with our property is first expanding out what we have. So x squared is equal to x times x, and x cubed is x times x times x. And then I can rewrite this. If I wrote this as one power, I have 5 x's here, so this is equal to x to the 5th. So hopefully you can notice, looking from the left to the far right, x squared times x cubed is x to the 5th. The 2 and the 3 to make a 5 was an addition. So a product of powers is made when we add our exponents. So here's our actual property. We have a to the n times a to the m equals a to the n plus m. Now it sounds like a different language here, but notice that the big points here to make is that our bases are the same. Those are both a, and they stay a. And then if the exponents are different, you can add them, or if they're the same, you can add them, I should say. Here's a few more examples of these so we can kind of power through a bunch of them. If I had 5, oops, I'm going to put this in a different color. If I had 5 to the 6th times 5 squared, and then notice here we've got the same base, 5, so I can add my exponents. My new exponent is going to be an 8. And then be careful here, my base is still going to be 5 because we had A and A and A. My base is still 5. The mistake I often see here is that you make your base now be 10 or be 25. Leave it as a 5. Our A stayed an A, so your 5 stays a 5. The 10 would have been made if you added those, but those are just regular numbers, so leave them be. Here's another one. If I had y to the 4th times y squared. One thing to notice here is sometimes they try to throw you off by giving you a variable without an exponent. If there's no exponent, there's an invisible 1 there. So we can add all of our exponents here. 4 plus 1 plus 2 is 7. So that's y to the 7th. Let's do one more. If I had 7x squared times 2x to the 5th, our numbers get multiplied like they normally do. 7 times 2 is 14. And our exponent portions, we can add those. So x to the 2nd, x to the 5th, there's a total of 7 x's there. So 14x to the 7th. That's our first property. Well, let's look at the next one, quotient of powers. So here we go. Quotient of powers is going to look like a fraction, like x to the 5th over x squared. And let's do the same thing we did last time. Let's write it out the long way first. So x times x times x times x times x over x times x. If I write it out the long way, notice that there's some canceling I can do. I've got an x over an x. Those can cancel to become a 1. So can these guys. So I'm left with just x times x times x, or x cubed on the top. So looking from the left to the right, x to the 5th over x squared equals x cubed. It was a subtraction, and I remember this one by noticing 5 minus 2, like the minus as if it's the fraction bar. So 5 minus 2 is x to the 3rd. So our rule here is if I have a to the n over a to the m, that's equal to a to the n minus m. So top minus bottom. There's my next one. Let's do a couple examples of this as well. So if I had y to the 6 over y, notice again, my denominator has an exponent of 1. So this is y to the 6 minus 1, or just y to the 5th. The other way you can think of this is because of the canceling process, there were 5 leftovers in the numerator. So we have a 5 as our exponent, and our term is in the numerator. Here's another one. If I had 10a to the 7th b cubed over 15 a to the third b to the third. Let's see, let's treat numbers like numbers. So 10 over 15 reduces to be 2/3. And a to the 7th over a to the third, 7 minus 3 is 4. The leftovers are on the top. So a to the 4th goes on the top. And then these are going to cancel, the b cubed over b cubed. So that's all gone. So I'm all set there for that property. There is actually one other property that's hiding inside here that I wanted to show you. So let me give you one more example. Let's look more closely at what we did here, this b cubed over b cubed thing. So what I want you to notice here is because we had something over a self, we knew that it equaled 1. But if I looked at this also as the subtraction, it was b to the third minus 3. So like b to the 0. So here's the deal. Anything to the 0 equals 1. This is actually another property called the 0 property. So that's a whole separate property that was kind of hiding inside of a problem. All right, let's look at the next ones. Power of a power and power of a quotient. So power of a power, let's look at this example. X squared to the third. So if I was going to utilize that cubed on the outside, this would really be x squared times x squared times x squared. By product of powers rule, that means I add my exponent. So I've got x, 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 x. So 6 x's, or 2 plus 2 plus 2. So our rule on this one is that if we have a to the n to the m, you can just multiply the powers, because on here we did 2 times 3 is 6. So a to the n times m. All right, let's look at a couple examples of these guys. So if we had x squared to the 8th, we have simply x to the 2 times 8, or x to the 16th. Another one, what if I had, let's do 5x squared to the third. On this one, you can kind of just distribute this third in. So this was 5 times 5 times 5 is 5 cubed, and x squared times x squared times x squared is x to the 6th. So there's a couple more examples of those. Let's look at our last one on the front, product of quotients, and then we'll do negative exponents and be all set here. So power of a quotient is what it sounds like. There's a quotient like a over b and a power on the outside. If I were to write this out the long way like we've been doing, I'd have a over b times a over b times a over b times a over b 4 whole times. So on my top, I had a to the 4th, and on my bottom, I had b to the 4th. So this one is what you'd expect. It's kind of like a distribution to the top and the bottom. That's actually kind of what we did up here as well, is we distribute it into everything on the inside. So power of a power and power of a quotient, kind of think about distributing that in to each term on the top and the bottom. So here's our rule on this one. If I have a over b to the m, it is a to the m over b to the m. Let's do a couple examples and we're all set with these ones. If I had, let's see, x over 2y squared, I can distribute this into every term. And where I often see a mistake is that you don't forget to put it into the number term, the coefficient as well. So this is x squared over 2 squared y squared. So everything gets squared. Let's do one more of those guys. If I had, let's see, a squared over b cubed, to the 10th. I need to distribute that into each of my powers. And when I do, now all of a sudden notice this one has kind of two properties at once. Now that I have a squared to the 10th, there's a power to the power on the numerator now, which means I multiply. So I've got a to the 20th on the top, and b to the 3rd to the 10th on the bottom, a power of a power, so that's b to the 30th on the bottom. So that one had two properties at once. We'll get into more examples where there's multiple properties going on at the same time. We've got one more. Our last one is negative exponents. So if I had an example like b squared over b to the 5th, and I was going to use this like my quotient property, I would do my subtraction. So this would be b to the 2nd minus 5, or b to the negative 3. Now, that looks kind of weird as an answer, b to the negative 3. And it should. We don't ever have answers with negative exponents. So whenever I have that, I need to switch it around a little bit. And let me write this a different way. Let's write it out the other way, where we write it out b over b. So we know this is also b times b over b times b times b times b times b. Notice I've got a big equality statement here. Each of these are a different way to write the same thing. Let's look at how we canceled this. We would have been left with 3 b's on the basement, which would have left me with nothing up top. But because I canceled, I really have a 1 up top because that's all that was left. So our property here is that if we have a negative exponent, we can put it on the denominator and make it positive. So let me re-say that in the format we've been working with. So if I have a to the negative m, so anything to a negative exponent, you can flip it, do the reciprocal, I should say, and make it a positive exponent. So imagine that there's like a 1 under here, flip it, and then make it a positive exponent. You can do the same thing if it's negative and already on the denominator. So if I have 1 over a to the n, or I'm sorry, to the negative n, I can't really say that, a to the negative n, I can flip it, put it on the top, and make it a positive. So each one of these is a representation of this property. All right, let's do a couple examples and call it a day on these notes. Here's the first one. If I had, if I had 2b squared over b to the 5th, the 2 I can't do anything with, so just leave it. And the b's, I had 2 minus 5 is negative 3. It was on the top, now I'm going to put it on the bottom. So I've got 2 over b to the 3rd. The other way you could think about this is I've got extras on the basement. I've got extras in the denominator. So leave your leftovers where they need to be. So more of my b's are on the bottom, so they need to be left on the bottom. Let's do another one. 2 to the negative 3rd. Right now this doesn't have a denominator of 1, so I can put it in. It was imaginary. Now I can flip it and make my exponent be positive. So the big thing here is that standard form has all positive exponents. So if you don't have positive exponents, you need to move it to make it positive. We'll call it a day for these notes. I hope that these helped, and I will see you next time.